We're gonna go here. Oh, we're recording. Okay. No, we're sharing. No, we're recording now. Okay, very good. So good morning to pre-calculus people. We have today is our, or this week is our test review day. We don't have a test up just yet. I will work on that, but it's going to be due on Sunday at 11:59 p.m. So you'll have this week to work on it, and I will do my best to get that up sooner rather than later. So hopefully I'll have something done for you guys today. Okay, so format. I'm going to try to use the Connect if I can set up making it work in WebAssign. We'll work on that. But there we are. So let's see. We have. Let's go back to this for just a second here. So let's see. We are 1.8, 2.2, 2.5, and 3.1. So 1.8, 2.2, 2.5, and 3.1 for our subject material. Okay, that's where we went up to. That's where we're stopping. I know we started a little bit of logarithms last week, but the stuff that we're supposed to cover from weeks 1 through 3, weeks 1 through 4, go up, including 3.1. So that's where the test gets to stop. So you should probably go and look through some logarithm stuff so you don't forget between this week and next week, but you're not responsible for it yet. All right. So we have function composition here. Okay. We have part of function composition, all right, with is operations on functions, and we have the difference quotient. And we will definitely go over several difference quotients problems. All right, we have polynomials. So this is mostly graphing polynomials or constructing them based off of behavior. Okay, 2.5, this was rational functions. That's huge, right? That's rational functions. And I pull them out of your Connect Math homework. So you will be prompted with what to do the same way you're prompted in Connect. So if they're telling you to graph, right, they'll tell you to find a horizontal and vertical asymptote. They'll go ahead and tell you to plot 2 points on each side, that kind of stuff. Okay. Let's see here. And then 3.1, this was inverse functions. Okay. Just so you know, my favorite flavor of inverse function problem is when we have a rational function. Okay, and since we're going to be spending 4 days on this, we definitely have some time to go over some of the back stuff. But if I'm doing something and you want to see something again, please let me know. I have a couple of different focused videos for you guys to see, but if there's something there, we have a lot of time. We have and not a lot of people show up to the lectures. But if you want to shoot me an email and say, hey, I would really like to see this, please do that. Okay, so I know where to spend some focus time here. Okay, so let's just take a look at function composition. Okay, so we'll start off with a couple of difference quotient problems because I know that those are always a difficulty one. So difference quotient. Okay, now. So the idea for a difference quotient, I think they give you this most of the time, but I can't swear to you having this all the time. Okay, so you might need to memorize that formula, okay, for difference quotient, all right? And there's effectively 4 different flavors of difference quotients that your book asks you about, okay? You could do a difference quotient on a quadratic. Okay, you could do a difference quotient on a cubic. You could do a difference quotient on a rational function. That'd be a fraction. Or we could do a difference quotient on a radical function. All right. So those are the 4 different kinds of problems that we could ask you about. All right. So they each have their own little problems in different ways. They usually have more than one term for quadratics. Okay. So there's multiple terms. For cubic, this is just downright tedious. Okay. This is awful. Rational functions, you have to remember how to add fractions, so we're going to get common denominators. Okay, and then actually rationals are probably one of the easier ones to do because the functions are never that difficult, and all you have to do is get the common denominator and start processing it. They look terrible, but you know, these have a lot of work to them. And then the radical functions, this is the trickiest because you have to remember to multiply top and bottom by 1. Okay, the conjugate. Okay, the conjugate. So one thing I do want you to remember, because I even saw this in some of people's homeworks, was they got down to a value of 1. Okay, so remember what the difference quotient is. It is the slope of the secant line. So if you have just kind of some kind of a weird, function like this, what you're doing is you are figuring out the slope of the secant line. Okay, so just think about this curve, right? I mean, I pick these 2 points, and if I know my x and I know my h, we could get a slope of 1. That's okay. But some people come up and we get a slope of 1 all the time. And there's only one function that has a slope of 1 all the time, right? And that's y equals 1x plus b. So, I mean, actually, there's a lot of functions, but there's only one family, right? So there, these are the functions that will always have a slope of 1, okay? So unless they give you a line that looks like y equals 1x plus b, if you come up with an answer of 1, like your answer is just always 1, then you've done something terribly wrong. Okay, so I want you to remember that. Like, there's only one function that's going to have 1x plus b. And quite honestly, I'm not asking you that question. Okay, I'm not giving you a linear equation and saying, tell me what the slope is. Okay, that's that's a couple of classes ago. Okay, so we're not doing that. So just be careful. If you end up with a constant, the only functions that have a constant slope are lines. And unless you start it, I mean, it's possible, right? Here we can give you 3/5 x plus 7 and ask you what the slope is. But you don't have to go through all of this to get the slope. All you have to do is look at it and say, oh, look, the slope is 3/5. We're done. Okay? So you don't ever get an actual value for don't get something that doesn't have you plug in an x and plug in an h. Because if you do that, that means your slope is constant and you start with a line. So just be real careful because this is too easy of a question. All right. So with that, why don't we go backwards? Why don't we go from the hardest to the easiest here? So what if we have a radical function, right? We have f of x equals, and we'll just come up with a radical. We'll say something like x minus 7. Okay. Going back from your knowledge of college algebra, right, and sliding functions around, this is a horizontal shift 7 to the right, so 5, 6, 7. So we know the graph looks something like that, right? And then we would pick 2 points, excuse me, and any 2 points, doesn't matter, and then we would figure out the slope of the secant line. But if you don't know which 2 points to start with, sorry about my heater, what we're going to do is we're going to do this f of x plus h minus f of x all over h, okay? So we're going to go ahead and say we have the square root x plus h minus 7, right? Because everywhere I see an x, we'll put in an x plus h. And this is my f of x. Right? That's my f of x minus square root x minus 7. All right, that's my, so there's my f of x plus h, sorry, f of x plus h. This is my f of x. Okay, so f of x plus h, f of x all over h. All right. Now, you can't square this, because if you're going to square something, you have to square both sides. Right? So you can't square this. Your options are multiplying by 1 or adding 0. So the only two things you're allowed to do. So what we're going to do here is we are going to say, well, this is x plus h plus 7. Or no, we're going to keep that as a minus. We're not changing anything yet. X plus h minus 7. Here's the plus. Okay, it goes between the square roots. And then I can't just multiply by something like this, right? We got to divide by it too. All right. So even though this is a scary and horrible looking thing, it's just 1 because we got thing over thing. Right? And then we're going to go ahead and multiply through by this, right? So we have this square root times that square root. Since they're the same thing, we're just going to write down x plus h minus 7. Minus, okay, and I'll do the whole thing out here because I know for a lot of you, probably, okay, I got this. But for somebody, this is going to help. And we're going to multiply, so that's my inners, and we're going to multiply the outers. So it's going to be x minus 7, x plus h minus 7. Okay. And then finally, we have a minus, right? Because we have negative times positive, so we have a negative. Okay, and then square root times square root, we just have x minus 7. Now, on the bottom, we have a bit of a mess. But we're not going to do anything with that h, and we are not going to go through and try to factor through anything. We're just going to leave this alone and see what sorts out on the top before we mess with anything. Right? So, this is just the parentheses of the thing. This is just the parentheses thing. You see that we have a negative, horrible looking thing and a positive, horrible looking thing here? Well, these two, right, they're going to cancel each other out, right? Those are going to add together, and then we're not going to have anything there. Okay. So what we are going to get is x plus h minus 7 minus x minus 7, all divided by h square root x plus h minus 7. And then we have, oh, there's a plus in here. I shouldn't have closed my parentheses just yet. Erase. And plus square root x minus 7. All right. So what happens up top here? Right? We have, I'll stay with blue for just a little bit here so we can push this thing out. So we have x plus h minus 7 minus x. Don't forget this one, right? Negative times a negative is a positive. So be careful about that one. If you've done great up until now, that's the place where you're going to mess up. Right? Square root x plus h minus 7 plus square root x minus 7. Go away. All right. And then here we are, right? We're going to go ahead and cancel some stuff. So we have x and a minus x, so those are gone. Right? We have a minus 7 here, right? And a positive 7. So those cancel. So what are we left with on top? We're just left with an h, right? So we have an h on top. We have an h, and then we have a square root x plus h minus 7 plus square root x minus 7. All right. And then here we go, right? The last thing we're going to do here is we are going to cancel these h's, all right? Now, as terrible as these problems look when they're done, okay, and I admit, I look at them, I'm like, I know that's the answer. It doesn't look like an answer. You are done when you have canceled that bottom h. Okay, that is always the goal with these, is that you cancel that bottom h. Okay. When you're in the middle of calculus and you learn a different thing about that, you can come back and tell me, wait, that wasn't the goal here. We evaluated it. I'm like, yes, you did. But for now, every problem you're going to work, the goal is to get rid of that h. Okay. All right, and there we are. Okay, that is the difference quotient. So if they ask you the difference quotient of the function, there it is. Notice I have x's and h's in my problem, right? Because here's what our function looks like. If I'm going to ask you for the slope of a secant line, okay, we're going to need a couple of 2 points. They're going to be different, right, depending on my x and my step. Okay, so I give you an x, I give you a step, and then you're going to be able to calculate this thing. All right. And also, when I draw the picture, right, notice all of my slopes of my secant lines, right, no matter which 2 points I pick, they always have a positive slope, aren't they? And then this is a positive number, this is a positive number, right? Because we're taking the square root. So we're just getting 1 over a positive number. So it does make sense that, you know, whenever I draw this thing out, the drawing I'm getting is kind of consistent with my formula. Okay, so be careful about that. You can always, you know, if you go back and can look at this, you can always double check it. All right, why don't we try one that's a fraction? Okay, so why don't we do a 1 over, all right, how about we do a 1 over x, we'll do a plus 6 this time, right? Here's our function, and the instructions might be find the difference quotient. All right, find the difference quotient for this. So again, and by the way, if you're ever like wondering, like, how do you memorize the formulas that way? Every time you use this, you write it down. Okay, every time I use the formula, we write it down, and then we substitute right into it. So the first one I have is 1 over x plus h plus 6 minus 1 over x plus 6 divided by h. Okay, and again, what's the goal? The goal is to get rid of this h somehow. Okay, it's going to look a little weirder on a fraction, but we're still going to try to eliminate this bottom h. Okay, one thing I would always do when we had to write this stuff on paper is we could figure out and do this. We could say, you know, I've got a compound fraction, and how do we deal with compound fractions, right? We invert and multiply, right? Because really you got a fraction divided by a fraction. When you say divides, how do you divide a fraction? You invert and multiply. So an easier way to write this so you don't run through quite as much paper, you have fewer lines, is now I have 1 over h. Again, this is the h I'm trying to get rid of. And then it's times, okay, I don't know why that stray mark is in there. Excuse me. Okay. So what do we have left here? We have 1 over x plus h plus 6 minus 1 over x plus 6. So I would always like to write it that way for a couple of reasons. One, I only had to use 2 lines when I was writing this out on a pencil. And 2, quite honestly, once I took the compound fraction away, this looked far less scary than it is. Okay, so that was always something that I did when I was working these, just to make it a little bit easier to look at. But you don't have to. It's just doing like the almost last step first, but it's okay. All right. What we have to worry about is this stuff in here. We're just going to hold this 1 over h there until the end, but this stuff in the middle, that's what we have to work with. And very clearly now, right? You've got two fractions. You got a subtraction. How do you deal with two fractions? Well, we get common denominators and we add, right? In this case, common denominators and subtract. So it's going to be 1 over h, right? And then we have 1 over x plus h plus 6 times 1, x plus 6 over x plus 6, all right? Minus, oh, I didn't leave myself enough room. We have 1 over x plus 6 times x plus h plus 6 divided by x plus h plus 6. I get 1. Right. So what do we end up with? Well, we end up with 1 over h at the side here. Okay, leave that alone. And then we have an x plus h on, or x plus top. Okay, we've got an x plus 6 on the top. And on the bottom, we've got this terrible thing, right? We've got x plus h plus 6, x plus 6, minus. Don't multiply this out. Just leave it alone. Excuse me. Okay. Almost never do you multiply out the bottom of a fraction. Okay. It happens, but okay, we almost never, ever multiply the bottoms of the fraction. Okay, just leave them alone. And on the top here, right, so we took care of this business. Now we're taking care of this one. So we have x plus h plus 6 divided by, again, this horrible mess. All right. So notice that these are the same. All right. And now we're just going to subtract. Be very careful with your signs. Okay, I'm going to put them all together here and say this is x plus 6. And then we have minus x minus h minus 6. All right, be real careful with your signs that way. We have x plus 6, x plus h plus 6, and off to the side here again, we have this 1 over h. It's just hanging out. All right. So what happens? Well, we've got an x and a negative x. We've got a 6 and a negative 6. All right, let's combine and see what we have here. We have 1 over h here. We have a negative h up here. And on the bottom, we've got this horrible thing. Again, don't waste your time multiplying this out. Okay, this is not a good thing. And again, we have some h's that cancel. All right, look at that. That's gone. And then what are we left? That was our job, right? Our job was to eliminate that h. We have now done so. What we write down next, that will be our answer. And it will not look like an answer. All right, we have negative 1 over this horrible stuff here, right? This is x plus 6, x plus h plus 6. Does it matter if I swap these? No, not at all. But that is our, right? That is our answer. Okay, what does x plus 6 look like? 1 over x plus 6, right? That's a horizontal shift, right? 6 to the left. So we would 1, 2, 3, 4, 5, 6. And we have a little bit of an asymptote here, right? We're just going back and looking at 1 over x plus 6, right? So we know that we have a horizontal asymptote at y equals 0 because the degree of the bottom is 1 and the degree of the top is 0. Oh no, does this show up? No. Let's go with brown. Go with that brown. Okay, so we have y equals 0 as an asymptote. We have x equals negative 6 as an asymptote, right? I will leave it to you to plot 2 test points, okay? Oops, I want get rid of that. All right. Okay. I will leave it to you to put some test points in. After you've done a number of these, we kind of sketch this guy again real fast. Okay, but again, notice, all right, notice that any 2 points I happen to pick, okay, any 2 points I happen to pick, well, how's my slope doing? It looks like a negative number, doesn't it? it's a negative slope. Notice if I put in an x and an h that are close together, okay, we're going to end up with a negative slope. We do get a difference, right? When we go, if I wanted to do the difference quotient between, say, here and here, we get a positive number because it's on the other side of the asymptote. Generally, you don't see that. They usually pick one side, right, or the other side. They don't pick. So what about this one? Well, that slope is still negative, isn't it? The slope is also very negative. So this function is always, right, no matter what you're doing, this is always a decreasing function as well. So there we go with that. And again, it's discontinuity, right? That's what they call this, is a discontinuity. We pick the pen up and we take another spot. So we can start at a different place. And even though this looks like it's an arrow going up, it's really a discontinuity, because if you pick any 2 points and you want to ski down the slope here, you're always going to be having a good time. Sometimes too good of a good time, but you still have a good time. Okay, so that's how that looks. Okay, great. So that is a difference quotient with a fraction. All right. Let's go ahead and the cubics. I think the cubics we got were things like x cubed plus 2, kind of an idea, or x cubed minus 1. Let's do x cubed minus 1. I could draw that one a little bit easier. All right, x cubed, we'll say minus 1. All right, so if I graph this thing, all right, it's x cubed with a vertical shift of 1 down. So that would be our graph. And generally, if I'm going to pick 2 points, they're probably going to be x and h. They're probably going to be looking at a positive slope here. Okay, no matter which 2 points I pick. So let's go ahead and take a look at this. All right, find the difference quotient. So this is f of x plus h minus f of x all over h. And everywhere we see an x, we're going to replace it with x plus h cubed minus 1. That's how you substitute this in. Okay. Minus x cubed minus 1. All right, that's minus f of x, all divided by h. Okay, now this is going to be too much fun. All right. All right. So I went kind of in fast motion there of multiplying all of that out. I really didn't multiply it out. What I did was I used something called the Binomial Theorem. I encourage you to look at this, okay? If you go to like Purple Math or a couple of other sites, Binomial Theorem worksheet or something, you could look this up on YouTube. We will cover it at the end of the course, but you know, we're not there. Let me just warn you that they teach this everywhere from Algebra 1. Okay, some schools Algebra 1, not every school Algebra 1. Okay, all the way up to graduate level. Okay, so if you turn on a video, talks about binomial theorem, and they are going on about stuff, you're like, I have never seen this before in my life. Okay, you got one that was a little too hard. Okay, just like they teach reading from K through 12, and then you can get a whole PhD in literature. You get a whole PhD in reading. You got to pick the level that you're good at. You got to pick the level you're comfortable with in order to learn this stuff. But there is, maybe Algebra 2 would be a better way to go. Algebra 1 may be too small. But I guarantee you there is a high school level of binomial theorem. Take a look at one of, Purple Math is very good at high school type math, or, this level of college math. So if you're going to go there and look for binomial theorem, you will find a nice little explanation or worksheet to do that for us. Minus, okay, distribute negative, x cubed plus 1 all over h, right? And now we have some stuff that cancels, don't we? Okay. It occurred to me that explaining binomial theorem and where to find it, There's a -1 here, sorry. I forgot that one. Okay, but that's all gone. Okay, but binomial theorem, we're going to find it. Maybe take more time to do that than it would have taken just to multiply it out. So that didn't help. All right, what do we have here? We have 3x squared h plus 3xh squared plus h cubed all over h. All right, we just have these pieces left. And this is equal to 3x squared plus 3xh plus h squared all times h over h. Right? And now we're going to cancel that. And again, how do I know that we're done? You canceled that h. All right, that's how you know you're done. I cannot tell the difference between red and orange. All right, so our answer here, right, 3x squared plus 3xh plus h squared. Notice that if these are all positive, or actually if these are all negative numbers, they're all going to change positive. If they're positive, they're all going to be positive. So that's, you know, that's how we're going to see our difference quotient. Okay, last one. All right. Last one is going to be f of x equals, and they usually make this one a little bit harder, okay? They usually come up with an ax squared plus bx plus c. Now, I am not giving you just this thing to go figure it out, okay? There'll be an a and a b in there, okay? So I think one of your problems did something like this. It was like 11x minus like 3x squared or something. Okay, something like that. All right. I think that that's one point in here, but we'll just go with this. All right. So, difference quotient, f of x plus h minus f of x all over h. 11 x plus h minus 3 x plus h squared. Okay, this is f of x plus h minus x minus 3x squared. Notice when I do this, like my first line for working this problem is just filling in the formula correctly. I'm not trying to process anything by putting this negative sign through. No, that's going to happen in a little bit. My first line here is expand out the x plus h squared. Okay, I don't need binomial theorem for this. I think you guys are all good with being able to do this, right? I hope. Well, actually, I don't. I mean, if you have to wait, if you have to work this off on the side, you go right ahead and do it. All right, nobody's judging. Well, kidding, everybody's always judging, but don't pay that any mind to do that. Okay, you wait this out until you're comfortable not doing it. All right, someday that'll happen. You'll do like the 20th of these problems. You're like, do I have to multiply this out every time, or can I just remember this? All right, 11x plus 11h minus 3x squared minus 6xh minus 3h squared. And this is why I do it in like one step at a time, because I'm going to forget this one because it's the end. And I got excited that I got these two right, and I forget. Minus 11x, minus times a minus, plus 3x squared, and all over h. Right? So here we go. And those two things cancel. These two things, right? Negative 11x, positive 11x cancel. What are we left with? I'm usually looking at the f of x terms. Once you've canceled all the f of x terms, you're probably done canceling this stuff. Okay, so we have 11h minus 6xh minus 3h squared. All right, we're going to factor out one of the h's. Yeah, we're okay. And then we are going, yeah, that one's the right one. We're going to cancel those h's. Okay, and we are left with 11 minus 6x minus 3h. Right? And again, right, we had a parabola. We had something I would have a difficult time graphing right off the top of my head. But when x is 0, y is 0. And then we probably have to do something like this, 11/3 over here or something. But there's my parabola. Depending on what my x is, right, and what my h is, we could have a slope of the secant line over here somewhere. We could pick these 2 points for the slope of the secant line to get a slope of 0, or we could pick something over here. We could pick this one, this one and that one. And get a negative slope. It's fine. Okay, but notice as I move around this parabola and I change different points, I change my secants, right, we're going to get positive and negative slopes, and this will allow that, so all squared or anything. Okay, so there we go. All right. So that is there's all 4 flavors of difference quotient, and I guarantee you that there's a lot of difference quotient. Okay, calculus is built on doing difference quotients. We show you a couple of shortcuts to go a lot faster, but you're not doing this the whole time. But the first little bit that you're doing in calculus is all of this. Okay, it's the whole basis for the beginning. So understanding this is really important. Excuse me. This is the one I was trying to do. Okay, once you have this as a difference quotient, right? They're gonna give you what to type in for t and h in order to do that. Okay, here they're gonna want a formula like we just came up with, and then they're gonna want us to use them to generate different x's or different t's and different h's. Okay, so let's see here. So we can do some of these. Okay. So these are a little bit on the difficult side because they finally ask you to start thinking about things. But I also understand, like, they've never asked before, so why would you know? Okay. So for what does A1 x plus 6 squared represent? That would be this whole circle. This whole big circle would be what this is, right? Because it's pi and an r squared. R squared is x plus 6, so it's pi r squared. It's that big circle. The middle one here, pi x squared, this would be this smaller circle that's inside of this. And then they're saying take the big one minus the little one, right? So we've got a big circle. Pretend that's round. Okay, and then we have a little circle. Okay, again, pretend that's round. And they're saying take the big one, this was A1 minus A2. So what's going to happen here, right? We're going to get, that's not enough contrast, right? This is going to be, I should have done it with the blue still, but that's going to be gone. And you're left with a ring. Okay. So A1 minus A2, that's a ring. Okay. That's what they're asking. And that's the beauty of like function composition things, is the idea if we could keep things easy when we're formulating one part of it, and then we can combine them to make more difficult or more complicated shapes or more complicated ideas. All right. So we're not going to worry about that. Right. So something like this, right? P gives the distance traveled on the first day. Q gives the distance traveled on the second day. And we add them together and divide by 2. Well, I'll tell you, if you scored a certain grade on a first test and a certain grade on a second test, and you add them together and divided by 2, right? That's how you get the average. So that's all that would be. It's just the average. Okay. There you go. And max average. Okay. This is a great. I think I did this one for you guys. There might be a smaller video, but somebody may have asked, and it's in one of the lecture videos. But I have a feeling we're going to be looking at something like this again. I just wonder if we could do it. I wonder how many different attempts, how many different problems they have for this. All right, great. That's wonderful. Can I try another one? We're going to say try another. I'm going to see if they actually give me another one. Oh, they do. Oh, that's great. Okay. I'm always worried because the early times, in the early days of this software, they would give you try another one. It'd be exactly the same one. Try another. Exactly the same one. So, all right. With that, I think I'm going to let you go a little bit early today. That's fine because of other things we're going to do. But tomorrow we will come back and we will probably visit a problem like this. Okay, and then move on to polynomials a little bit. Okay, so I'm going to go ahead and stop sharing, and I'll read you. Okay, so stop recording rather. What do I want? I want to say stop.